Hey Calculus, we are going to go over these multiple choice questions. Feel free to scroll through the video for just the ones you need. So question 1, we've got this limit. If you plug in 2 for x, you do get 0 over 0, so do more. A couple options. One is to factor cancel. So denominator is the difference of perfect squares. Numerator is a trinomial, so what multiplies to be negative 6 adds to be positive 1 will be positive 3 and negative 2. So those eliminate, and now you can plug in 2 for x. And get d. Another option is to apply L'Hopital's rule. So derivative of the numerator is 2x plus 1. Derivative of the denominator is just 2x. Plugging in 2 for x, again, gives you 5 over 4. Question 2. We've got f of x, and we want to find f prime of 2. So no special rules. F prime of x is 3x squared minus 2x plus 1. Plugging in 2 for x gives me 3 times 2 squared minus 2 times 2 plus 1. Make sure you do order of operations here, so 3 times 4, 12, minus 4, plus 1, so 9. All right, so which of the following definite integrals has the same value as that one? So notice that we do need an anti-chain rule here. Your outer function is e to the x, and your inner function is x squared, okay? So I'm going to anti-derive the outer, which is just itself. Now hold everything else, the x squared and that factor of x. That's step 1. Step 2, divide by the derivative of the inner. Again, the inner is x squared. So when we divide by that, we get 2x. X divided by x is 1, so those go away. So I have 1/2 e to the x squared. And I want to evaluate this at x equals 4 and 0. So this gives me 1/2 times e to the 4 squared, so e to the 16, minus e to the 0. And I recommend just kind of leaving it unsimplified like that, because now you can hopefully match it to a correct option. I see that I need a 1/2 out in front, so that eliminates those 3. And then this part, the antiderivative of e to the x is e to the x, and I want to evaluate it at x equals 16 and 0. So this. If you're unsure, take your options and find that integral. So I have 1/2. That integral means to antiderive, but an antiderivative of e to the u is itself. And this would be plugging in 16 and 0 for u. So this gives me exactly what I had here. Question 4, which of the following is an equation of the line tangent to the graph of x squared minus 3xy equals 10 at the point 1, negative 3? So really I just need to find dy dx, the slope, because that's the only thing that's different in all of these options. If you look, you are going to need, looking ahead a little bit, you're going to need product rule here. The biggest mistake is dropping that negative. So just think of that as negative 3x times y, and you'll do pretty well. We are going to derive with respect to x, so derivative of x squared with respect to x is 2x. Now I need product rule, so derive the first is negative 3, hold the y. Now switch it, hold the negative 3x, derive y is dy dx. So we're deriving with respect to x. And then derivative of 10 is 0. Now go ahead and plug in 1 for x and negative 3 for y. So I've got 2 times 1 minus 3 times negative 3. Minus 3 times 1 dy dx equals 0. So I've got 2 plus 9 minus 3 dy dx equals 0. 2 plus 9 is 11, but then when I bring it over here, this is negative 11. So dividing by negative 3, I get positive 11 over 3. Question 5. We're given g and we want to know where g is decreasing, so make a sign chart for the first derivative. So if I apply that 3 to the 1/3, it's just 1x squared. Similarly here, the 2's will cancel and you just get 3x minus 70. Let's factor. So it multiplies to be negative 70, adds to be 3. So positive 10, negative 7. So my critical points are negative 10, positive 7, g prime, and g. And I want to come back here to find, this is g prime, remember, I want to find the sign of the first derivative. That tells me the direction of the original. You can start on any interval you want. Like maybe I'll plug in 0 and test this middle interval. So if I plug in 0, this becomes 0 plus 10, which is 10, and then this becomes 0 minus 7. So a positive times a negative is negative. I don't have any even powers here, right? I don't have any even multiplicities, so I know I have to switch at each critical point. So g goes increase, decrease, increase, so from negative 10 to 7. All right, we want to antiderive and evaluate here. If you take off the 5 and the negative 3, you can see that the parent function here is 1 over x, whose antiderivative is ln. Then hold the inside. And then don't forget to divide by the derivative of the inside, which is negative 3. So I'm going to multiply by negative 1/3. We're going to take this and evaluate at x equals 4 and 2. So if I plug in 4, I get ln of 5 minus 12 in absolute values. Minus, plugging in 2, I get ln of the absolute value of 5 minus 6. All right, 5 minus 12 is negative 7. Absolute value of negative 7 is positive 7. 5 minus 6 is negative 1. Absolute value of the negative 1 is positive 1. But ln of 1 is 0. So I've got negative ln of 7 divided by 3. Question 7, we have the function f, and we want to know the instantaneous rate of change of f right at 3. So that's the derivative. So 3x squared, no special rules, minus 12x plus 8. So f prime of 3 will be 3 times 3 squared minus 12 times 3 plus 8. This is 3 times 9, so 27 minus 36 plus 8. 27 minus 36 is negative 9 plus 8. There's our negative 1. Question 8, it says a particle moves along a straight line. The graph of the particle's velocity at time t is shown above for time between 0 and m, where j, k, l, and m are constants. The graph intersects the horizontal axis at time 0, time k, and time m, and then has horizontal tangents at time j and l, which we can see from the graph there. Then it says for what values of t is the speed of the particle decreasing. A couple ways to do this. I think the fastest way is actually to just draw the graph of speed, and remember that speed is the absolute value of velocity. The given graph is velocity, so if I want to take the absolute value, I can't have any negative values. So this part of the graph is fine for speed. The other part needs to, and I'm running out of space, I'm sorry, needs to be flipped over the x-axis. So, for example, whatever this, why this is negative 5, now I need to have a value of positive 5 there. So that blue graph is now the graph of speed, and I want to know when speed is decreasing. So that will be from j to k, and l to m is one way of doing it. Another way is to look at the original and say, okay, for speed to be decreasing, velocity and acceleration have to have opposite signs. So the given graph is velocity. So velocity needs to be positive, and acceleration, the slope, needs to be negative. So the given graph would be positive and decreasing. Or the opposite, the given graph, the original graph, would need to be negative and increasing. So a couple ways to think about it there. All right, you have a function f here. We want to know for what values is f not continuous. Think back to Algebra 2 and pre-calc. This is where you would have vertical asymptotes or holes. So anywhere your denominator is 0. So x equals 2 and x equals negative 1. X equals 2 would be a removable discontinuity because you can, remove that factor, but it didn't ask for removable or non-removable. It just said list all of them. So anywhere your denominator is 0, your function value is not defined, and you'll have some kind of break in your domain. Question 10, a particle moves along the x-axis with velocity given by v of t for a time greater than or equal to 0. If the particle is at position x equals negative 2, at time t equals 0, what's the position of the particle at time t equals 3? So hopefully you can see this is FTC rearranged. You're given one function value. You're given that x of 0 position at time 0. The initial position is negative 2, and you're trying to find the position at time 3. So you're given one function value, asked to find a different one. So position at time 3 will be equal to position at time 0 plus how far you've been displaced from time 0 to 3. Okay, again, f of b equals f of a plus the integral from a to b of f prime. So let's go ahead and just plug in v of t here. V of t is 3t squared minus 4. So x of 0, again, was negative 2. Here we will anti-derive, so t cubed minus 4t. Evaluate that at time 3 and time 0. Plugging in 3 gives me 27 minus 12. Minus, plugging in 0 just gives me 0. And we've got we should be getting 13 there. All right, we have f defined by this integral. We want to know on which intervals is the graph of y equals f concave down. So we need to analyze the second derivative, the sign of the second derivative. So the first derivative is second FTC. Replace your t's with your x. So 2x cubed minus 15x squared plus 36x. And then the second derivative will be the derivative of the first. So 6x squared minus 30x plus 36. Let's solve by factoring. So factoring out a 6 gives me x squared minus 5x plus 36. Plus 6. Factor that trinomial. What multiplies to be 6 adds to be negative 5. So negative 2 and negative 3. So my critical points are positive 2 and positive 3. I'm coming back to the factored form of the second derivative. So if I plug in something in the first interval like 0, 6 is positive, 0 minus 2 is negative, 0 minus negative 3 is negative, so positive times a negative is a positive. Again, I don't see any even multiplicities, no powers of 2, 4, 6, 8, etc. So this will switch every time. Again, this was the sign of f double prime, which tells me the concavity of the original, and I want concave down, so from 2 to 3. Alright, for which of the following does the limit as x approaches infinity equals 0? Remember, these are horizontal asymptotes, so just Bobobot needs DC. If I want a limit of 0, I need my scenario of Bobo. Remember your order of growth. So your sine and cosine grow the slowest, then your logs, then your polynomials, then your exponentials. So for number 1, your polynomial grows faster than a log, so that is bigger on bottom. For number 2, your bigger is on top. E to the x grows faster, so that's a no. And then for number 3, again, exponential grows faster than a polynomial. So we will keep 1 and 3, so option E. All right, question 13. It says, let f be a differentiable function such that f of 0 is negative 5, and the derivative is always less than or equal to 3 for all x. Which of the following is not a possible value for f of 2? So this is a version of mean value theorem, okay? So if the derivative can never be less than or equal to 3, then the average rate of change can't either. So, or is always less than or equal to 3, then same for the average rate of change. So we've got, let's set up the conclusion of MVT. F of 2 minus f of 0 all over 2 minus 0 always has to be less than or equal to 3. F of 2 is what I'm looking for. F of 0 is given to be negative 5, so minus a negative 5 is plus 5. And now just solve this inequality for f of 2. So go ahead and multiply by 2 and subtract 5. So f of 2 has to be less than or equal to 1, so the only option that doesn't fit there, 2 is not less than or equal to 1. All right, let f be the function given above. What are all values of a and b for which f is differentiable at x equals 1? Well, to be differentiable, we first have to be continuous. So let's set the originals equal to each other at x equals 1. So the top becomes 1 plus b. And we'll set that equal to a times 1 squared, which is just a. Okay? Now, let's do the same thing with their derivative. So the derivative of the numerator is just 1x plus b. The derivative, not the numerator, the derivative of the bottom piece is 2ax. So now set those pieces equal to each other at x equals 1. So when I plug in 1 here, I get just 1. When I plug in 1 for x here, I get just 2a. So now that second equation allows me to solve for a. So a is a half. Plug that in here, 1 plus b equals 1 half. So b is negative 1 half. All right, last one. You have a function defined by f divided by g. So if I want k prime of x, we need quotient rule. So derive the first, hold the second, minus, reverse it, hold the first, derive the second all over the original denominator, squared. And now we're going to plug in x for 3, but those are the only values given in this table. So f prime is 5 times g is 2. Minus f is negative 1, g prime is negative 2, all over g of 3 is 2, and then we want to square that. All right, 5 times 2, 10, I see 3 negatives there, so that's minus 2 over 4. There it is.